Hello, Algebra 1 students. This is Mr. Ford here with another homework tutorial. This is for 714 Part 1, Problems 747 through 752. I've already taken the liberty of drawing a graph for 747, so if you need to, you can pause this video right now and take a look at that graph. But if you're reading the question carefully, what's going on here is that a local business has agreed to donate boxes to collect shoes in. The key is that each box holds 20 pairs of shoes. So we're drawing a step graph here that relates the number of shoes collected to the number of boxes needed. The idea here is that if you have anywhere from 0 to 20 shoes, you only need one box. But as soon as you hit 21 shoes, suddenly you jump up to the next level where now you need two boxes because 20 shoes fit in one box and then the overflow can fit into the second box. And then so on and so on and so on. Anything between 40 and 60 requires three boxes, and between 60 and 80 requires four boxes, and so on and so on and so on. So there's how this one works. Let's look at the next question, 748, which if you took the quiz today is going to help kind of understand what's going on here. Assume that a DVD loses 60% of its value every year it's in the store. Suppose the initial value of the DVD was $80. So right away I got two pieces of information here. The initial value is another way of saying the zeroth term or the y-intercept. So if this is going to be a y equals a times b to the x situation, I already know that a is going to be $80. That's what the starting value is going to be, because they told us the initial value is 80. The losing 60% each year is going to be a little trickier because b is the multiplier. It's tempting to put 0.6 here because you're losing 60%, but we really got to think about this. If you're losing 60%, this means you're keeping 40%. And so what we're really going to do here is we're going to use 0.4 or 0.40 for b because 40% is the remaining value, what's going on there. So we actually just answered question A. What multiplier would you use to calculate the video's new value? What you want to do is 1 minus r is really what's going on here, which in this case is 1 minus the 0.6, which is where I got 0.4 from. That's where the b is. You know, if you're losing 60%, you're keeping 40%. What's the value of the DVD after 1 year? Well, that would be the original $80, which is pretty expensive for a DVD. $80 times 0.4, which on my calculator, which I'm going to bring up to the front of the screen here, $80 times 0.4 is going to give us $32, so that's how much it's worth after 1 year. Now, if I wanted to do after 4 years, what I would be doing is taking the $80 value, multiplying by 0.4 times 0.4 times 0.4 times 0.4. That's a lot of work. I do not expect you to do all of that. What I need you to see is that multiplying by 0.4 4 times is the same thing as taking 0.4 to the fourth power. So that's what we're going to do on the calculator. 80 times 0.4 to the fourth power. Whoops. I forgot to put a number in the box, which is $2.05 if we're rounding up. That seems small, but it is. 40% of your value, 40% over 3 years, that's not a whole lot left over. So as far as writing a continuous function to model the value of the DVD after t years, well, we've kind of already done this too if you've mapped out what a and b are. We're just going to use this general skeleton up there, but instead of saying y equals, we're going to use v of t equals. We're going to write that v of t equals $80 times 0.4 to the t power, like that. So any number of years that goes by, you just plug in that number for t, and that tells you what the value is. When does the video have no value? When it hits 0, that will never happen. Losing 40% of your value every time, it's never actually going to go away. So this never happens. A mathematical way of writing this is that 80 times 0.4 to the x power will never equal 0. You can never get an exponential function to be 0. It's going to get really, really close. And yeah, eventually the value will be so small that it's actually less than 1 penny. So according to the American monetary system, yes, it's got no value, but it's always got something. As far as sketching a graph of this function goes, it's pretty easy to do. We'll do it right here in this little corner right there. We'll put years down here, and we'll put value over here. We already kind of know that 0.80 is the beginning point of this agreement. And then every year it's going to lose 40%. 1, 2, 3, and 4, and 5, like that. we kind of calculated that after the first year it has $32 of value. So if that's 40 right there, 32 is probably a little bit below that. After 2 years, it's, at this point you can kind of just eyeball it. You're just going down by 40% every time. So a little bit less than half, like that. So the graph should look something like this. It's got an exponential decay to it. You can see it's never going to be 0, though. Let's look at the next question. This is the checkpoint question of the assignment here. We're going to talk a lot about this next week after we do the NWEA. A lot of work in this one. You got to really read everything. So the key here, before we do anything, is you got to read everything. If you don't read everything, you're not going to know how to do this. I'm telling you right now. So I'm going to come around to your table, and I'm going to be like, what's going on? You'll be like, oh, I'm stuck. I'll be like, did you read it yet? And you'll go, no. And I'll go, well, you got to read it first. We're going to read with a pen or pencil in hand. You're going to highlight, underline key phrases, because that's really the idea here. Let's talk about question A. The Lees have 3 children. The oldest is twice as old as the youngest. Bam, right there. Already, I'm thinking about O being equal to 2Y. O for oldest, Y for youngest. Sure. The middle child is 5 years older than the youngest. So M equals 5 plus Y. Look at that. Already we've translated 2 English sentences into 2 mathematical sentences. And I honestly, if you're the kind of person that's frustrated by this class, I hope you're really not frustrated by those 2 things. And if you are, take a breather and look at them real seriously. That's not very difficult to do. Now, the sum of the 3 ages is 57. This is where you got a little bit of a jump to make, because you got to know what the word sum means. We're adding everything together. So the oldest plus the middle plus the youngest, that's 57. Now, in my head, the way to do this is by doing a substitution, because we already kind of figured out that the O, the oldest child, is actually twice the youngest child. And the middlest child is 5 plus the youngest child, plus the actual youngest child's age, and that's 57. So what we're doing here is a substitution. We're replacing the oldest child with twice the youngest, and the middle child with 5 plus the youngest, because those are the 2 things they gave us in the above problem. And now it's just a matter of simplifying and solving. Now it becomes an algebra problem. 2y plus y is 4y plus the 5, which equals 57. You subtract 5 from both sides, you get 4y equals 52. And now if you divide by 4, y is equal to 52 divided by 4, which is going to be, on my calculator, I could probably do this by hand, but whatever. It is going to be 13. Cool. Now, that's not the answer to the question, because they did ask us how old is each child, so we got to kind of go back here. We know the youngest child is 13. That means the middle child is 5 years older, 18, and the oldest child is twice 13, 26. There you go. And it's worth, on the calculator really quick, to confirm that 13 plus 18 plus 26 is, in fact, the magic number, 57. Bada bing, bada boom, bada bam, easy peasy. Just keep your head on a swivel. Keep confident. You can do it. Question B. In Katie's garden, there are 105 ladybugs. They are increasing at 2 ladybugs per month. There are currently 175 aphids. Actually, let's stop there. That's the first sentence, I think. There are 105 ladybugs increasing at 2 ladybugs per month. So I think that is 105 plus 2x. And this is for ladybugs. So I'm going to put an L in front of that. 105 plus 2x. There are currently 175 aphids, and the number of aphids is decreasing at 3 aphids per month. So aphids are currently at 175 and losing 3 every month. And I guess in this case, x is the number of months that have gone by. When will the number of ladybugs and aphids in Katie's garden be the same? Okay, so we're looking for when ladybugs and aphids are equal to each other. So all we really got to do is plug in and solve these problems. 105 plus 2x equals 175 minus 3x, like this. So at this stage, we're going to add 3x to both sides to combine our like terms. We'll keep 105 hanging out over here, plus 5x equals 175. Now we'll subtract the 105 from both sides. Cancels out over there. You get 5x equals 70. 175 minus 180, 105, 70. There you go. And now divide by 5 to get the answer. 70 divided by 5 is going to be 14, and I suppose that is the answer. 14 months is what it takes for them to be the same. That's it. 14 months. 14 months. 14 months. You know, I noticed just like, you know, if anybody's watching this video with the sound on, I just noticed that a lot of students just watch this and write the answers down. That's fine. I want you to have the answers. That's why I make these. But you gotta believe in yourself. You can do this. You do not need me to show you the answer. You can do this. You can do it. You do not need me. Let's talk about question C. At the farmer's market, Laura bought 3 pounds of heirloom tomatoes. If the tomatoes are priced at $8 for 5 pounds, what did Laura pay for her tomatoes? So, okay, we know that it is $8 for 5 pounds. I think this is a good example to do division. $8 divided by 5 pounds. I'm using the dollar symbol and the pound symbol here. The reason why I'm doing that is because when I divide 8 divided by 5, I get 1.6. But the number is less important than the unit. This is dollars divided by pounds. In other words, that's dollar per pound. Or I suppose if I spell it out, $1.6 per pound. So what we're looking for, this is what's called a unit rate, which I remember teaching in middle school a long time ago. We're looking for how much money it is for 1 pound of tomatoes. Because now that we know that, she bought, what, 3 pounds? Yeah. She bought 3 pounds, and it's $1.6 per pound. So at this point, we're going to do 3 pounds, I guess I'll use the pound symbol, times $1.6 per pound. And I like to spell it out with the units there because I want you to see, and your science teacher does too, I want you to see what's going to happen here. The pounds are actually going to cancel out because it's pound divided by pound, and that cancels. What's left is dollars, and that's exactly what you want. It's $4.8. Actually, you know, the way we write dollars is backwards. It's $4.8. Like that. For 3 pounds. And let's look at one more problem. Adult tickets for the school play cost 5 and student tickets cost 3. So let's do $5 times the number of adults plus $3 for the number of students. I'm already seeing that adult tickets are $5 and student tickets are $3. So already putting the pieces together like that. We also know that, look at this, 30 more student tickets were sold than adult tickets. So this is kind of weird and backwards, but the way that you want to think about this is if you do 30 plus the students, that is the number of adult tickets. Or do I have that backwards? 30 more student tickets. That's backwards. See, these are confusing to me sometimes. So if you take the number of adult tickets and add 30 to it, that's the number of student tickets. Because the number of student tickets is more. That's what you want to think about. Student tickets is 30 plus A. Something like that. And we collected $1770. So that we'll stick that onto this because we did add up to get $1770 right there. So $5 for every adult plus $3 for every student. That was the total of $1770. That's equation number 1. And then we know that the 30 plus A is the students. Now, once we got all that, now we got to solve this problem by substitution. So we're going to plug in, I'm going to use a different color highlighter, blue. Oh, shoot. We're going to plug in the 30 plus A for the S on this one. So this is 5A plus 3 times 30 plus A, which equals 1770. Like that. Getting a text message here. Ah, cool. Sorry, I'm recording a video. I forgot where I was. All we got to do here is distribute the 3 and solve for A. So let's start by distributing our 3 by we're multiplying. So this is 5A plus 90 plus 3A, which equals 1770. Then we're going to add together the 5A and the 3A and get 8A plus 90 equals 1770. We'll subtract 90 from both sides. And we'll get 8A equals, let's see, this is 1770 minus 90, which is 1680. Just using my calculator for that quick calculation. And I'm going to divide it by 8. And I would definitely need a calculator for this. Nobody is expecting that you know how to do 1680 divided by 8. But I'm getting 210, which is a good, cool whole number to get for that answer. So the number of adults is 210, and we sold 30 more student tickets than adults, so the number of students is 240. 30 plus 210. Pretty cool. Hey, we have a checkpoint quiz coming up, and that's the thing you got to be able to do. This is a pretty tough checkpoint. I'm going to tell you that right now. I know you can do it, though. You just got to practice a little bit. We'll be we'll have a lot of opportunity for practicing next week as we wrap up the NWEA. Also, we got some more problems to do. We're not even close to being done with this assignment. This is a long one, so this video is already 15 minutes. Here we go, 750. We're going to multiply and simplify each expression below. Classic problem with question A, what you want to remember is this is actually a generic rectangle problem. X minus 3 times x minus 3. You're going to get x squared here and positive 9 there. But you also have a negative 3x and a negative 3x in these two boxes. So it all becomes x squared minus 6x plus 9. All there. For question B, this is kind of the same thing. Always think about this like a generic rectangle problem. It's 2m and 1, 2m and 1. And we're multiplying. So 2m times 2m is 4m squared. 1 times 1 is 1. 1, I said. But then you get 2m times 1 and 2m times 1. So there you go. And this gives us 4m squared plus 4m plus 1. It's the 4m in the middle that people get thrown off by. Right there. Down below, we got a couple more. Now, maybe you're getting pretty good at this and you don't want to use the generic rectangle. That's fine. This question's kind of tricky, though. I would start by distributing this x in the front. Right there. I would call this x squared minus 3x. And, you know, you can skip the generic rectangle at this point. If you don't want to do it, you don't have to. I think it's a fantastic organizer, though. Because that's all it's about. It's about making sure you get every combination here. You got to make sure you get every possible multiplication between the two things on the left and the two things on the right. We got an x to the third here. We got an x squared times 1 there. Now we get minus 3x squared there and a negative 3x there. And now that you got all those things, we can start to add them together. We do have some like terms, as we usually do in those two slots. So we got x to the third minus 2x squared, because that's negative 3 plus 1, moving one step back towards 0, minus 3x, like that. That's my solution for this problem. And then question D, which is right here. Again, I think this is a good one to do a rectangle for. You get 2y minus 1, y squared plus 7. So you got 2y to the third in that bottom left slot. 2y times 7 is 14y on the top left. Negative y squared in the bottom right, and negative 7 there. None of these are like terms. Although if I'm being real specific and talking about things that nobody cares about, they should go in order descending in degree. So I'm putting the y to the third power first, followed by y squared, followed by y, followed by just a number. Just like that. Hey-oh! Okay, let's talk about some more stuff. Consider the sequence 2, 8, 3y plus 5. Consider the value of y if the sequence is arithmetic. If the sequence is arithmetic, then we got to think about our pattern. How do you get from 2 to 8? By adding, and the answer is by adding 6. And that way the next number should be 8 plus 6, which is 14. So in this case, the problem is 3y plus 5 has to be 14. Now instead, if we multiply, so I'm looking ahead at the next question, what if we do geometric? 2 times 4 is 8, and 8 times 4 is 32. So down here we got to solve 3y plus 5 equals 32. Okay. So we basically have two small algebra problems to solve here for these two different answers. It's all about what 3y plus 5 equals. In this case, 3y equals 9 and y equals 3. And in this case over here, if you subtract 5 from both sides, you get 3y equals 27 and y is 9. There you go. That problem looks really difficult if you read it first and you have no idea what to do, but if you just think about it a little bit, it's actually really simple. So hopefully by watching the video, you get a little bit of that hint there. And of course, we got diamond problems. They're very small. I do have some of the answers already written on this one, so I'll just place them up here. Just remember the key goes like this. You got x, you got y. Up here, you got x times y, and down below, you got x plus y. That's the pattern. So the reason why I know it's got to be 8, because 8 times 1/2 is equal to 4, and 8 plus 1/2 is 8.5. Or you could write 8 and 1/2 if you want to up there. It's okay. Question B. Again, this one, they gave you the numbers, so all you really got to do is think, what is 0.3 times 0.2? And you can go on a calculator if you don't know it, but it's 0.06. The trick there is to remember to add the 0 in as you go. And then if you add them together, it's just 0.5. Over here on question C, now we're getting tricky. We don't know what the two numbers are, but we do know they multiply to 11. The nice thing there is that 11 is what's called a prime number. Only two numbers multiply to 11, and that is 1 times 11. And thankfully enough, 1 plus 11 is 12. So 1 and 11. That's all you need. And then finally, we got question D over here, which has given us one of the two numbers, but not the other one. So we kind of have a little simple problem to solve. Is -3 plus what number is -4? And so that's got to be -1. And then when you multiply, up top, -3 times -1 is +1. And there you go. Hey, hope you enjoyed this. It got kind of long there. There's a checkpoint question in there, and we'll have to talk about that checkpoint quite a bit. That ate up most of our time on this assignment. So I will see you in the next video, and you guys are awesome. You can do it.